Now that we have an understanding of how to find horizontal asymptotes, the true base, and identify the general shape of a function, we should be ready to construct a graph. Okay, so what we want to do for each of these is we want to identify, is it a growth or a decay model by identifying the base? Is it a positive or a negative growth or decay model based on the a value? Figure out where is the horizontal asymptote, find the y-intercept, and then at least one other point, plot the points in the HA, and then draw our graph. Okay, so we're going to start off by figuring out what the base is here. And the reason why we don't know what the base is yet is because there is a negative in front of the x, okay? So what we're dealing with is we have y equals 2 times 3 to the negative x plus 2 minus 1. Okay, so I need to factor the negative out of the exponent. So I'm going to make that 2 times 3 negative 1 times x minus 2 minus 1. Okay, so I'm going to apply that negative 1 to the 3. So that's going to make this into 2 times 3 to the negative 1 power is 1/3. And then I have x minus 2 minus 1. Okay, so that means that the base in this problem is 1/3. Meaning we have a decay model because it's less than 1. All right? Because the a value, the number out in front of the base, that is a positive, we're going to have a positive decay model. So positive decay model has this general shape. So our graph is going to look something like that. Next up is we want to identify our horizontal asymptote. Because we know every single one of these graphs is going to have a horizontal asymptote, we want to be able to write its equation. Remember, HAs are always y equals a number. The HA is whatever is being added or subtracted after the exponential. So we have an HA at y equals negative 1. So I'm going to go ahead and draw that right on my graph. Y equals negative 1. I have a dashed horizontal line there. So there's my horizontal asymptote. Okay. So next up, I'm going to find the y-intercept. And to find a y-intercept, all we need to do is plug in x equals 0. Okay? So we can really do this from the original function or from the rewritten function. Because the base was originally a 3 instead of a 1/3, I'm going to go back to the original here. I think it'll be a little bit easier to evaluate. So I'm going to do y equals 2 times 3 to the 2 minus 0 is just 2. Minus 1. Make sure you follow your order of operations here, okay? So this is 2 times 3 squared is 9. Exponents come first. So then I have y equals 18 minus 1, so y equals 17. Okay? So I have a pretty high y-intercept. It's at 0,17. So because I'm counting by ones, where I put my horizontal asymptote, that's not really going to fit on the grid the way that I have it. So I'd either need to go back and scale or find some additional points to see if I can get closer to that horizontal asymptote. Okay, so we're also going to find some additional points. Now, one thing we are not going to focus on finding is the x-intercept. Finding the x-intercept is something that's going to be a pretty complicated process that we're going to be looking at later in the chapter. Okay, so you have your HA, you have your y-intercept, we know the general shape, we want to find some additional points, and since we know this function is decreasing like this, it's going down from left to right, since I already had a pretty big y value here, let's do numbers on the right of x equals 0, so that we can get closer to the HA. So I'm going to try plugging in, say, 1 or 2 or possibly even 3 and see what I get, okay? And remember, when you're plugging these in, you can plug them into the original function as it was provided to you, or you can go to your rewritten function. But I like to go back to wherever there was a whole number base if I can. Okay, so if I go back to the original and plug in x equals 1, that's going to basically take all the work that I did over here, and it's going to take this exponent and turn it into, let's see, 2 minus 1 would be a 1. So that means that 9, that would switch to being a 3, And then that 18 will become a 6. And this 17 will become a 5. So this is me plugging in x equals 1. I got 5. Okay. So I'm going to plot that point. So I have the point 1, 5. 1, 2, 3, 4, 5 is up here. So that's my first point. Let's make that a little bit bigger, easier to see. There we go. Okay. So now I'm going to go ahead and do another exponent. Okay. So I'm going to now go back and plug in a different exponent, see what we come up with. Okay. So I'm going to plug in x equals 2. So that means the exponent is going to be 2 minus 2, which is really just 0. And we know that any number to the 0 power is really just a 1. So now I have 2 times 1 is 2. 2 minus 1 is 1. So I have the point 2, 1. So if I plot that point, 2, 1 would be right about here. All right, I'm going to do one more because it's not really clear exactly what this shape is going to look like just yet. So I'm going to go through and do this one more time. I'm going to plug in, whoopsies, I erased a little bit too much that time. It's all right, go back and write that in. There's a 2 there. This was our 3. All right, there we go. So if I plug in x equals 3, 2 minus 3 will give me an exponent of -1. So 3 to the -1 power, that's 1/3. So this is going to be 2/3 minus 1, which is -1/3. So my third point is 3 -1/3. Okay. So if I go to plot that, 3 -1/3 will be just below the x-axis. And now I can see that it's leveling off a little bit. I could keep going and plugging in more points. I could even go back and change my scaling so I could plot that y-intercept of 0, 17. But I think at this point I have enough information to draw my graph. So we're going to start up here and then bend down because we know what the general shape is back from over here. Okay. So that is graphing y equals 2 times 3 to the 2 minus x minus 1.